All right. Thank you for having us over here. I feel like I have to run to give a talk. So I try to be short this time. All right. I'm Surachet from Thailand, and my presentation will be very short under the title of Utilization of Sodium Bentonite to Ameliorate Acid Sulfate Soils in an Agricultural Pond, Thailand. This work is a collaboration between Department of Soil Science, Faculty of Agriculture, Kasetsart University, and Project Environment Management Department, PTT Public Company Limited. A little bit about PTT. PTT is a state-owned oil and gas company that develop and run energy infrastructures in Thailand. PTT's natural gas pipeline network includes about 4,500 kilometers of both onshore and subsea pipelines, including those areas where we found a lot of acid sulfate soils. PTT therefore plays the importance of the environmental management along with the project development. The construction of natural gas pipeline in some areas totally needs the horizontal directional drilling or HDD technique to build pipelines underground crossing the obstacles like agricultural fields, rivers, or even the agricultural ponds that we really interested in this study. HDD technique generally use sodium bentonite as a drilling mud, and the point is that this alkalinity, according to sodium bentonite, might be useful for reducing the acidic condition of acid sulfate soils. One of the major problems of the acid sulfate soils is the oxidation of pyrite. So that leads to severe acidity and aluminum toxicity to crop and water quality in agriculture. So for any kind of disturbance of the surface of the acid sulfate soil, including the pipeline construction, that could lead to this problem. But for HDD technique with the sodium bentonite as drilling mud, we might get the different result and more interesting. Based on our previous study, recently actually, earlier this year, we found that using sodium bentonite could decrease the pH/BC of the soil and also raise the soil pH to the desired pH. So it's pretty useful for the acid sulfate area. A little bit about the pH/BC. To find the pH/BC of one soil, we need to know the pH as a function of A, where A is the amount of the acid added or amount of the alkali added. And we switch them around to A as a function of pH, make a derivative out of it to get the pH/BC. In general, for one soil that has the higher pH/BC, it means that it would be more tricky to change the pH of that such soil. So in the case of acid sulfate soil, we like to decrease the pH/BC. To our objective of this study, we expand a little bit according to the concern of the farmers, where they have a lot of agricultural ponds nearby the construction of the pipeline. And we think it's going to be a great idea to monitor the positive effects of the sodium bentonite on the agricultural pond where we see a lot of the acid sulfate soils. Here's our experimental layout. It's 12 agricultural ponds were activated right at the Land Development Department in Pathum Thani province. It's pretty easy to drive from Bangkok up north about 1 hour to get to this area. The dimension of the volumetric pond is about 3 by 3 by 1.5 cubic meter. The RCBD 3 treatments with 4 replications were applied to these 12 experimental units. The first one is the control, the second one, or T2, is the sodium bentonite, and the last one is the mixture between sodium bentonite and dolomite. And the rate for the sodium bentonite will calculate based on the pH/BC. For the data collection, we measure pH, pH/BC, iron, aluminum, extractable acidity, aluminum saturation, effective EC, sodium adsorption ratio, ESP, and soluble sodium in water. And here again is the experimental plan that you can see in detail of the 12 experimental units after we apply those 3 treatments with the 4 replication. And here's the result. As you can see, it's pretty obvious that using sodium bentonite or sodium bentonite with dolomite can significantly increase the soil pH from roughly 3 to about 6 after 3 months of the treatment application. And also, we found that using sodium bentonite can decrease the pH/BC of the soil, about 1/3 proportion. And this is totally significantly different in terms of statistics. For the total iron, aluminum, cadmium, lead, chromium, and arsenic, we didn't see any difference among these 3 treatments. But what interesting is we found that for the extractable aluminum, using sodium bentonite and sodium bentonite with dolomite can decrease the extractable aluminum. And these results corresponding with the extractable acidity. For the aluminum saturation, you can see that using sodium bentonite or sodium bentonite with dolomite can suppress the aluminum toxicity below the critical aluminum toxicity, which is 60%, from the initial after 1, 2, and 3 months after the treatment application. However, for the effective EC, we found that using sodium bentonite and the mixture treatment can significantly increase of the effective EC. However, this value is still in the normal range for the soil. For the ESP and SAR, we are totally aware of using sodium bentonite and sodium bentonite together with dolomite can significantly increase ESP and SAR. Especially for the SAR, that's the number is quite high. That's why we track on the soluble sodium in water, and we found no difference in water among these 3 treatments. So it's likely that sodium bentonite, after we apply to the acid sulfate soil, those sodium will be replaced by the proton in the acid sulfate soil solution. And then you get the acidic bentonite clay. And those sodium will absorb to the clay of the acid sulfate soil. From our results, we can make a conclusion right here that using sodium bentonite and the mixture of sodium bentonite with dolomite could raise the pH of the subsoils underneath the agricultural ponds, generally from pH of 3 to around 6. And sodium bentonite can improve the pH/BC by they decrease the pH/BC value. So that means that in the future, if you like to lift up the soil pH, it will be a lot easier for this type of soil. Sodium bentonite could suppress severe aluminum toxicity and acidic condition based on the percentage, based on the decreasing of a percentage of aluminum saturation. And using sodium bentonite to improve pH could also increase the SAR. We are aware of this issue, but it didn't raise up any soluble sodium in water. With that, I'd like to spend a few seconds to say that save the soil, to save the world, and we more than welcome to celebrate our World Soil Day 2018 in Thailand. So I would like to welcome everybody if you go to Thailand sometime this year. All right. Thank you. I'm more than welcome to take questions if you guys have any. Thank you so much.
Thank you very much for sticking also so nicely in time. So indeed, this is open for questions.
Yes, even in Japan, some very old fatty rice field has a sulfur problem. In that time, for mitigate that effect, we use steel making slab. Then we iron with a small amount of phosphorus. That will stop H2S, hydrogen sulfate, and not that reduce damage to rice root. Do you have such a countermeasure, or of course pH management is important, but the other countermeasure like steel making slab, using steel making slab or something. Do you have such a technology in Thailand?
Yeah, well, yeah, for solar, of course, but and this work is a drilling mud, which is it's totally normal of the drilling mud that people use for the HDD technique. We do have the problem like you have in Thailand as well, so but it's quite a little bit off of my topic today. But I just want to share that yeah, we do have that problem, and we try to control the property of solids before used to eliminate the soil problem. But in our case, this is actually we try to get rid of the waste of the sodium bentonite. But we see some benefits when sodium bentonite exposed to the acid sulfate soil. So, I answer your question?
Yeah, it's enough.
Okay.
Yeah, thank you very much.
Okay, thank you very much.